Hello, my name is Dr Loconsole, and together with Jonathan Stancher and Elisabetta Versace, I conducted a study on a spontaneous crossmodal association between visual size and auditory pitch in the tortoise Testudo hermanni. If you listen to the following sounds and have to guess which of the two discs produced which sound, what would your answer be? Most of you would probably say that the larger disc produced the low-pitch sound and the smaller disc the high-pitch one. This is an example of pitch-size crossmodal association, where we spontaneously match the visual information about size and the auditory information about pitch. These could be predisposed associations that reflect a systematic co-occurrence in nature, helping to make prediction about the environment. For instance, due to the physical constraints of the vocal tract, it is more likely that larger animals will produce lower sound than smaller animals. Different species might have evolved with similar expectations, leading to shared spontaneous crossmodal associations. However, literature so far mainly focused on mammalian species and one bird species only, hindering a proper understanding of the phylogenetic history of this phenomenon. Our study filled in this gap by describing a case of pitch-size association in a reptile. We hypothesized that, similar to humans and dogs, tortoises would preferentially match low-pitched sounds to a larger disc and a high-pitched sound to a smaller one. We trained animals in a corridor with two doors. Tortoises had to push one door open to approach the source of a background sound, alternating low and high pitch to locate a food reward. To test, the same sound, either high or low pitch, came from both sides, making the auditory information no longer reliable. If tortoises can exploit on a predisposed pitch-size association to determine which door is the more likely to generate the sound, they should choose the one with the smaller disc on it when hearing the high-pitched sound, and the one with the larger disc on it when hearing the low-pitched one. Each subject underwent 24 consecutive trials, and overall tortoises showed a higher probability to choose the congruent association. These results indicate that the reptile can rely on spontaneous associations between modalities like mammals do. However, the preference for the crossmodal association decreases along trials. We suggest that, when tortoises first encounter the two shapes, they use crossmodal associations to predict the most probable source of the sound, hence performing above chance level for the first part of testing. Yet, after multiple experiences of the pitch-size association not being rewarded, tortoises could have stopped relying on the expected association and started behaving at chance level. In fact, for the crossmodal mechanism to be efficient, it also must be flexible and thus subject to extinction or habituation to account for specific environmental situations that work against the predisposed behavior. Our work represents an essential step in developing our understanding of the evolutionary origin of crossmodal associations, revealing commonalities in the perceptual organization of phylogenetically far related species.